Hello all and welcome back. So in this video, now let us try to dive a little deep into our reverse linked list question and see if we can make it a little bit better in terms of complexity. So let's get started. Now in the last video, we saw that how we were able to reverse a linked list, but we were using this particular loop and we were using the recursion calls, right? So I asked you to calculate the time complexity of this particular code, right? So let me just copy this code and have it on our notes. Second, yeah. Overall, I think many of you will remember this is similar problem which we faced in our take input function, right? So in our take input function as well, this kind of problem we were able to see. Now, when talking about the complexity, right? The way we are just reversing our linked list, we have multiple steps. So the very first thing is that we are making this recursion calls, right? So for number of nodes, let's say if we are dealing with n nodes, we will of course be making n such calls. And each call is doing some work. So in accordance with the way we learned about time and space complexity, that is going to be somewhere On, right? So we know that at least the complexity is going to be On because n recursion calls are going to be called for a linked list of size n, right? Great. Now, if we move forward and see this part of the code, I think this is where the major work is happening because everywhere else we are just doing some constant work k, right? Now, in this code, just like we were doing in taking the input, we are trying to find the tail, right? Now, finding the tail, this overall operation, finding the tail, we have seen that it is O of n in terms of complexity, right? So we have two parts of this particular code, recursive call O of n, and with that recursive call, we have this finding the tail. So in each and every call, again, when we are to the outermost, let's say when we are doing our work initially, we have to do it for n minus 1 node, right? The next one will have to do it for n minus 2 node. So some k work for these many nodes. Now we have seen this multiple times now, how this transforms. So let me write it as well. First node, the work we have to do is somewhere around n minus 1. Second, n minus 2. Third, n minus 3. And towards the end, when let's say there is just one node, we have seen that for the last node, maybe if I write, some constant work of course is getting done, which is k, right? So all these will be multiplied by k, right? So this can be just k, n minus 1 k, n minus 2 k. Now again, we have seen this multiple times. This gets added and the complexity comes out to be O(n) square. If you have less idea on how this is getting calculated, a humble request to please go and see the time complexity module. There I have taken so many examples and explained you from scratch that how exactly you can calculate the time complexities. Okay, great. So with that in line, let us just also try to visualize and see if we can make something a little bit better. Okay, great. So yeah, let us go to the code once everyone. This is the code which we wrote, right? And in this code, we have passed this 1, 2, 3, 4, 5. So a better way to actually help you think about this, let us go to Python tutor and see what exactly is the visualization, right? Now I've already pasted this particular code, the same code, and let me make it just a little small so that we are able to handle this particular linked list. Okay, so let it do it. Let us first now jump to case when will we have the linked list. I think this is the case, right? So we have the linked list now with us. Now I'm calling this reverse linked list. So pay attention everyone. I call reverse linked list. It is called with this head. Base condition is going to get check. Head is not none. Neither it's a tail node. Now we know that head dot next is not none means it is not a tail node. So we are going to move forward. Another function call is going to get made. Then another function call. And lastly, on 4, is where I can say that my base condition is reached. Once the base condition is reached, I'm going to just return the node as it is, because if you just ask me that, hey, can you return this node? Sorry, can you reverse this node? I will say yes, I can. It's just the same node because it's a single node. This removal of overall pointer will be helping you to think, because this is how our reverse linked list will be getting the input. Okay, great. So now let us move forward. Now let us see what exactly is going to get returned. This is going to get returned, right? This small linked list has get returned. Now I'm going to make a temp. Temp is here, and temp dot next is none. So we get out. Now temp dot next, I'm saying that, hey, make this head. So this is how it happened. It is connecting with this. And finally, I'm going to make it none, right? So this is small linked list as of now is my linked list, right? And I want you to all to be very much comfortable and pay a lot of attention, because if you do, in middle of this run, in middle of this whole visualization, you will be able to actually just get a eureka moment where you will see that yes, this can be done pretty nicely. Okay, so please make sure that you focus on this visualization, everyone. Okay, great. So move forward, return value head, and we have returned this small linked list, which is 4 3. Now 4 is the head. I need to make sure that I've reached the tail of this linked list. So pay attention, everyone. I can remove this as well for the timing. This is the linked list which we have returned, and you will see that I have actually reversed some part of my linked list, right? So let us move forward. Making a temp, we are moving to temp and reaching the tail. We reached the tail, right? And now we have to just connect it. So temp dot next, I have to make sure that I connect this. Okay, so this is connected. See, temp dot next, and now let me make this connection invalid. And we have done the same thing, right? So great. Now let us move forward. Return value is this, and you can see that we have some list with us, right? Great. Let us move forward. I hope you are all able to see and actually work on the pointer. Please make sure that you just pause and see what I'm trying to find and how am I finding it. Let's move to the next. We have make a temp variable. It's going to move all the way till 2. Temp, temp. It find that it is the tail because next is none. And now I will be adding 1 after this and making the next none. And when I come out, you will see that the whole linked list has returned. See, this was my head, and the whole linked list has reversed. So we are able to see the linked list is reversed, right, everyone? Great. So yeah, I hope the overall visualization helped you a lot. Now let us see that, everyone, from this visualization what we were able to learn. One thing which we learned was that this function was the bottleneck. This function is the bottleneck. We are doing major work in finding detail. Now, one more thing which all of you can do, and I will highly request you all to do that is, instead of along with head, what you can also ask your recursion is to give back tail as well. Okay, so if you remember in the take input function, we were making and maintaining a tail variable as well, right, everyone? So you can do a similar thing. You can ask your recursion to give you head as well as tail. If you do that, then it will become a little easy. Then you can just do tail dot next. Okay, so I hope you are able to understand this. I want all of you to try this out. I can just give you a hint what I'm suggesting at, and you will be trying this out once. I am saying that along with this head, return the tail as well. Now, when this is none or a single node, head and tail both are same. In these examples, along with this, okay, we find out the tail and it was in temp. So return this tail as well. And then when you catch it here, when you catch it here, you won't have to run this loop because you will be getting this tail. Okay, everyone. So I hope that is clear as well. I think you will be good to write that out. Okay. So just give it a try. Pretty sure that you will be able to write it. All I'm saying is, let me make a copy so that you can write it. Reverse linked list with tail returned. Okay. So in this, what all you have to do, you will be catching a tail here as well. So tail, tail. Okay. Tail in this case is going to be head only. And in the base call, you can return both of them. Here you are getting the tail. Now once you have the tail, if you remember in the take input function as well, tail dot next, I can just directly connect my head. Okay, so I'm just writing a note here. Please complete this code. So you will download this file and make sure that you complete the overall code here. Great, everyone. So pretty sure you will be able to do this now. Okay, great. But I would like to be a little smart about this thing and actually think a little bit, right? So let me just now take you back to the whiteboard or the blackboard. Now let's pay attention, everyone. Where were we spending our time and what we have to do? Let me add a page. So see, when I had this linked list with me, 1, 2, 3, 4, and 5, right? And this was none. All the work I was doing. So once I passed this in recursion, I was getting answer as 5, 4, 3, 2, and none, right? This is what I'm getting the answer, and I have one node with me. All the work I was doing was to start from here and go till the end. I find the tail of the reverse returned linked list, right? That was all the work I'm doing in the last code which we wrote. If somehow I have tail knowledge, then I think a lots of work can be avoided. Okay, so I'm pretty sure that you will be able to think a little bit on this. If somehow I have this node, then I can actually avoid a lot of this work. Now, if you think in the initial linked list, don't you see that 1 is connected to 2 only? And this 2 is something which I want to find. This will be the connection, everyone. Yes or no? This connection will still be there, right? This connection overall will still be there. Something we have seen. Now, if you were following the visualization a lot properly in the Python tutor, so let's go back and let me show you that here and there as well. See, if I go back to, let's say, the last call when we were having the head as 1. Yeah. See here. So when I get this small linked list head, okay, this is a reverse linked list. So let me show you this, everyone. This whole is my reverse linked list, right? Now, what I used to do, I used to take this as temp, then make my temp here, then make my temp finally reach here. But don't we have this next already having the overall location of tail? Okay, so now I hope you're able to see this, everyone. Let me just draw it again. I need to find this tail, right? This tail is something which I need to find, this node. But don't we have this already in my head dot next? So don't you think that all the work which we did, that was in a way not required? Okay, so I hope now you're able to see this and now you're able to actually understand how how the visualization of this concept is a lot helpful. So just now what we have to do, I can just maybe do one thing. Let me copy this code. So even you don't need to return the tail as well, though I will still expect that you will complete this function, but pay attention, everyone. Instead of doing all this, what I can say, tail of reversed list is going to be head dot next, right? This is what the tail is, head dot next. So instead of going all the way through my reversed list, I can just directly get the tail. And when I have the tail, once I have the tail, it's pretty easy, no? Tail of links dot next is going to be my head, and head dot next is equals to none. So yeah, just by being a little smart, seeing our linked list a lot better, we were able to again reverse our list. So let me make a reverse linked list better. Reverse linked list better. And let me call this function. And if we run this now, so let me just remove this for the time being. See, we are able to get the list reversed, right, everyone? So yeah, pretty sure now you will be able to actually understand everything, what happened. Again, I will just show you the visualization once again so that you can get it. See, in the next step, which I'm going to do, I'm going to make a temp. This temp starts from this head of reverse list. It's going to go to 4, then 3, then gonna stop at 2. But if I want this 2, I have this directly here. Okay, so I don't need to do all this stuff. I don't need to do all this work which I'm doing here. Instead, I can just directly get the tail. This is something which we saw here as well. to get to this particular node, I already have this saved in my head. Okay, so just try to draw multiple examples. I will say at least 3-4 examples. Try to draw that and you will understand how this is all getting connected. And once I have used this overall knowledge, then my linked list is going to work fabulously well again. And doesn't matter how long it is. Now the complexity again is just see. So we are able to like return this whole list. And the complexity of this, I think all of us can understand. Just the recursion call is getting made and each function is doing some k work. So O of n. Now I'm not running any other loop. Okay, everyone. So I hope this was clear, rather a lot clear. I wanted to showcase this to you, the above approach, before I can actually make sure that you understand why this one also works. So I didn't directly start with this one so that your overall knowledge horizon gets opened. Okay. So great then everyone. Please make sure that you see this again if you have any doubt, though I have tried to explain it multiple times using visualization and example. But yeah, just these pointers can be a little bit tricky to get initially, but I'm pretty sure that we all will be able to do so. Okay. So yeah, in the next video, we are going to do the same thing iteratively, something which have been asked, I think 10 plus for tier one companies. So we should also master that. And yeah, let's meet in the next video, everyone. Please make sure that you just try to complete this code as well. Thank you.